All right, people. Check. Hello, people. Okay, I'm getting the audio out. Looks like everything is fine from my end. And I need to lower one volume from the feedback because you will keep hearing my voice twice otherwise. All right, so here we are with a new topic, and that is one-dimensional motion with uniform acceleration. That's the topic for today. This is one-dimensional motion with uniform acceleration. Do you guys think you have seen this motion before, this kind of motion? Or is it a new thing for you? Well, I bet you have seen this motion before. It's a very simple motion. If you have an object which is moving in a certain direction, okay, and let's say it is moving along this line. So, and this is the velocity vector. Let's say it's called as u, the velocity vector. Okay. So that will make it one-dimensional motion because the object is moving only along a straight line. And this one-dimensional motion, let's say it is encountering a constant acceleration, which means this blue vector that you see, acceleration a, which acts along the line and in the direction of motion, or if you have this pink acceleration which is opposing the motion. So two cases are possible. One is a bar is along the line of motion. Number two is a bar is opposite to the, in fact I should not say I should say a bar is along the line of motion in the direction of motion. And second case is a bar is this pink vector that you see, that also is along the line of motion but in opposite direction to motion. So I can call this blue vector as a along, and I can say this pink vector as a opposite. If this is the case, and if this a bar is not changing, okay, this a bar is constant and this a bar is constant. So a bar is a constant, remember, which means both the magnitude and the direction of the acceleration vector is not changing. If that is the case, then it's also said to have uniform acceleration. So this is the motion that I'm talking about. Okay, have you not seen this motion before? You have. If there is an object which is moving along a certain line, and if it is subjected to either an acceleration which is supporting its motion and along the line of motion, or an acceleration which is opposing its motion but again along the line of motion, then that is known as one dimensional motion with uniform acceleration. Let's say, let's look at a different case. Okay, let's say here you have an object and this object is moving. Hello, Avni Kumar. Let's say the object here is moving along this line. Okay, so this is your line of motion, and you have two kinds of accelerations. Let's look at case 1. As the object is moving along this line, let's say there is an acceleration which is supporting, so a support, let's say. Okay, it is supporting your motion. So what will happen with time? Hello Ashrit, good afternoon. What will happen is, with time, this black vector will increase in length. So by the time your object comes here, this black vector, velocity vector, would have increased in length because this a bar is supporting your motion, right? A bar is supporting your motion, so velocity will increase in magnitude. If velocity will increase in magnitude, velocity vector's length will increase, right? So either you can have this case or you can have this case where this is your line of motion, object is here moving with a velocity v, and now let's say it started to experience an acceleration opposite to its motion. So what will happen? By the time the object comes here, velocity vector, which was this long, would decrease. It will become shorter. It will become shorter. Why? Because now your acceleration is opposing. In other words, this pink vector is known as deceleration. You have heard this word before, right? Deceleration. So both these cases, case number 1 and case number 2, these two cases represent one dimensional motion with uniform acceleration. Okay. Now guys, there are 4 equations which are used for a case like this. Right now you are not expected to know the derivation for these 4 formulae, but after you by the time you end kinematics and you have gained some mastery on applying calculus to kinematics, then you will also be expected to know why these formulas exist. Okay, I'll anyways tell you right now also, but even if you don't understand, it's fine. Okay, so this is the object moving with a velocity v, and along its line of motion, let's say there is an acceleration a. So you have the following equation for this motion. Final velocity, let's say it's moving with an initial velocity u. So final velocity vector is equal to initial velocity vector plus acceleration vector into time. This time is a scalar, remember. These two fellows are vectors, and your end result also is a vector. You have seen this equation before, haven't you? You have. Next you have final velocity vector square is equal to initial velocity vector square plus 2 into a bar dot s bar. This is nothing but your v square minus u square equal to 2as. Instead of treating them as numbers now, instead of treating them as scalars, now I am treating them as vectors. Okay? Because now we have learnt vectors and we know that every physical phenomena will be represented using vectors. Right? Wherever the given physical quantity is a vector, we will have to represent it using a vector. This is the second equation. Third equation is displacement, which is a vector, is nothing but initial velocity vector into time, which is a scalar, plus half into a bar, which is a vector, into time, which is a scalar, square. Okay, please look at the terms carefully. Whatever is a vector has an arrow on top of it. Whatever is a scalar does not have an arrow. Okay. And by the way, this is displacement vector. If your particle started from initial displacement 0, if your particle started from some initial displacement s naught, then that s naught's position vector also has to come. Okay. So what I was meaning to say is, in three-dimensional motion, let's say your object starts from the origin. If it starts from the origin and it's moving along a straight line, if it starts from the origin and it's moving along a straight line such that this is the scenario, then after a time t, if I want the position vector, which means if I want this displacement vector, I will get it using this equation. But if your particle did not start from origin, if it started from some other point whose position vector was s naught, and now it has started to move along a straight line where all this is happening, and if I want the final displacement vector s bar, where this is my s bar, then I will also have to account for this initial starting position vector, and that I will do by adding s naught bar to this equation. Okay. I know, guys, it's getting a little confusing for some of you, because suddenly instead of using numbers I've started to use vectors, but as we solve some problems it will start making sense for you. So please don't worry, okay, because the concept that I'm giving you is extremely powerful, and it will ensure that if here in this case, if the object is thrown up or if it's thrown along some diagonal, no matter which direction it is thrown, no matter how it's moving, it will always obey these rules. So you just need to understand and remember these 4 equations, and with the help of this you can handle any motion. Yeah, Akshat, you had the derivation of these formulas in 9th, and I think you had that using graphs. Where you had displacement time graph for s equal to ut plus half at square. How do you get it? How do you get v square minus u square equal to 2s? I think it was all using graphs. But now you will not do it using graphs. Now these derivations come from calculus. In fact, graphs and calculus also are related. You will probably not understand right now, but as you learn more and more calculus, you will realize that graphs and calculus have a very close interrelation. So all these formulas that you're seeing, you will derive it from just calculus, where acceleration is nothing but dv bar by dt, where dv bar is nothing but change in velocity, which is vf minus vi by the time taken, let's say it is t. Then from here itself you get your first equation, vf bar is equal to vi bar plus a bar into t. So this equation that you see, this and this are the same, right? How do you get displacement vector, when this is the case? So displacement vector is nothing but, let's say your velocity at a given time is t, so that into dt, you'll have to integrate it from 0 to t, and vt is nothing but vi bar plus a bar into t. You have to do dt for this, and how do you integrate? You'll get v bar into t plus a bar into t square by 2, right? This is how this s bar's formula has come. Can you see there is integration, there is differentiation in the derivation, and you will understand all this. You will be in a position to understand this once we cover some other topics also. But yeah, remember, initially you only had graphs as your friend in class 9th and 10th as far as your derivations were concerned. Now calculus and vectors along with graphs are your new best friends, which will help you handle any case in the physical world. Okay, so let me rub this. Right now I'll not jump into this, because right now we only care about the formula and how to apply this formula properly. Okay, that we will do through some problems. So this is s bar equal to, and there is one more which probably you did not know, and that was, if you want the displacement in the tth second. So what does this formula represent, by the way? This formula represents that, okay, if the body is here now, then from the starting position, how much it has gone forward, or which means I want the position vector of the object after a time t. So from the start, what is the displacement? From the start, what is the displacement? That is got by using this equation. But let's say I don't care about the start. I care about the displacement in the tth second, which means my object, let's say it starts from here, it goes a little far. By the time it reaches here, uh, uh, this was the displacement after after t seconds. It was here, and in the tth second, so from t to t plus 1, let's say the object moved this much. Okay, then how do I get this vector, this pink vector? What does pink vector represent? It represents the displacement in the tth second, which means from time s equal to t equal to t equal to t plus 1, how much did it move? That is represented using st bar. And how is st bar different from s bar? S bar is from start, how much has the object reached from the starting position, and st bar is in the tth second, what is the displacement, and that is got using this formula. You need the initial velocity vector, you need the acceleration vector, you need to multiply this with time, and then you need to subtract half of the acceleration vector. Basically, you need to multiply the acceleration vector with t minus half. This is a new formula for you guys. The derivation comes from the first three formula itself. Actually, it's a simple derivation. So how do you get this displacement, people? This displacement in the tth second is nothing but this displacement, like from start to t plus 1, and then you subtract from start to t from that, you'll get this. So how do you get the displacement which was covered from start to t plus 1? Using this formula, u bar into t plus 1 minus plus half into a bar into t plus 1 whole square, and you will have to subtract the displacement which was covered from start to t, and that was u bar into t plus half of a bar into t square. And when you carry out the subtraction, you will get this result. When you carry out that subtraction, you will get this result. Okay, so this is again an important formula to remember, and you will use it for certain problems. I will say that for 90% of the problems, these three formulae are enough. But there are some questions where knowing this formula will be very useful. So I've given you 4 formulae today. You have seen some of these before, but you did not see them as vectors before. You did not know what v bar was. You just did v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2s. Now I'm asking you to treat these quantities as vectors. Don't treat time as a vector because time is a scalar quantity, but other quantities in the formula are vectors. Treat them as vectors. And why am I putting so much emphasis on this? Because now you'll realize when I give you the first problem for today. And mind you, people, I have not given you the derivation of these 4 formulae. You will know the derivation once I discuss the case of one-dimensional motion with non-uniform acceleration. When I discuss that case, which is the next class itself, while doing that, I will give you the derivations for these equations of motion also. Okay, it's going to be useful for you guys. All right, moving on. The question goes like this: a ball is thrown upwards, and people, you are going to get difficult questions now. I bet, but you will crack those difficult questions if you have an understanding of these 4 formulae. A ball is thrown upwards from the top of a tower 40-meter high. A ball is thrown upwards from the top of a tower 40-meter high with a velocity of 10 meters per second. Find the time when it strikes the ground. So when vectors are multiplied, we have to do the dot product of or cross product. You will have to do the dot product here. That's why, see, in the formula itself I have mentioned it has to be dot product, and there is only one case where vectors are being multiplied, that is here. In all these formula that you see here, vector is multiplied to a scalar, here vector is multiplied to a scalar, here vector is multiplied to a scalar, and even in this fourth formula vector is multiplied to a scalar. This whole thing is a scalar only in one formula, which is this. Two vectors are being multiplied, and that's why I've given, strictly I've given that there it's a dot product. Okay, and why is it a dot product? Because when you do vf square mod vf bar square, which is nothing but mod vf square, this will give you a scalar. So when you square a vector, actually you are squaring its magnitude only, because squaring a vector means doing the dot product of the vector with itself. Squaring a vector means doing the dot product of the vector with itself, which is nothing but mod v cos 0, because angle that a vector makes with itself is 0. So forget about this, it will become mod v square. So when I say v bar square, it means mod v square only, because v bar square means I'm doing the dot product of the vector with itself. Okay, so when you do it, you will get a scalar here. When you do this uv square, you will get a scalar. Now if your LHS is a scalar and one term of your RHS is a scalar, then the other term also has to give you a scalar only. No, this can't be a vector, because equation will remain it will become non-consistent. Your LHS is going to be a scalar, whereas your RHS will be a scalar plus vector, and you guys know that scalars and vector can't be added. Have I given you any operation in vectors where scalars and vector are added? No. You had lambda a bar where scalars and vectors are multiplied, but did you have a lambda plus a bar? No, this is invalid. This is not allowed. So that's why this quantity also has to give you a scalar. And if you took a bar cross s bar, then you would get a vector as a result, correct? So then that would become wrong. That's why because you need a scalar from here, I'm taking the scalar product, dot product of a and s. Okay, I hope that helps. Okay. So let's come back to the question. Find the time when it strikes the ground. When it strikes the ground. Okay, please people, I know you can solve this using your 10th class kinematics knowledge itself. Probably, I hope most of you will be able to solve it just with your 10th class knowledge, but I want you to use these vectorial equations instead of, forget about your 10th class equations now, they are gone. Now you will have to treat these quantities as vectors, and I want you to apply the vectorial equations to solve it. And if you don't get it in 1 minute, I'll do it. So I'll just have water and come. Until then, you guys try. Okay, so we are back, and I will do this problem for you slowly and properly using those equations, which will teach you how to apply those vectorial equations to problems. And trust me, it's very easy, but very effective, guys, very effective. You will, for life, you will not have any confusion whether you should take a plus or minus, because when you don't use the method that I'm going to teach you, you will have lots of confusions while solving the problems, whether you should take a plus or a minus, whether you should take plus 10 minus 10. Those it can get really confusing. So do it clean and do it properly. So as I told you, in every physics problem, start underlining. A ball is thrown upwards. Okay, it's thrown upwards from the top of a tower of 40-meter height. So first let's use this part of the question. Whatever data we have got, there is a tower having a height 40 meter, and from the top of this tower you are throwing a ball upwards. Okay, and it is thrown with a velocity of 10 meters per second. So okay, this blue vector is having a length 10 units because the velocity is 10 meter per second. Now the question is, find the time when it strikes the ground. So if it is thrown at t equal to 0, then what will happen is this ball will, and also see, I have finished underlining the entire question now, which means I have used every part, every data that's given in the question. I told you that's a pro tip. Keep using that in physics. Do not take any data for granted. Every data is useful to solve the problem. Very few problems exist where a certain data is not useful and it's given just to confuse you. Okay, so from t equal to 0, this ball is starting. It will go up for some time. Then what will happen is it will stop, and then it will start falling freely, and then it will reach the ground. Now the question is asking you, from here to here and then from there to down, how much time has elapsed? What is the time when it strikes the ground? So what will happen is when the ball goes up, it will cover this much displacement in a time, let's say t1, and when the ball comes down, let's say it took a time t2. So if you add t1 plus t2, you will get your answer. Okay, you will get the answer. First of all, I'm doing this problem, I'll continue, but I just want to know, can you guys do this problem on your own? That is the because I want to know the level when you come out of 10th. What is your level? When you see these problems for the first time, are you in a position to do it by yourself? Yes or no? Just type a yes or no in the chat box. Can you do this on your own? I believe that if you were able to, then I would have had some answers in the chat box. But regardless, come on people, waiting for your response. Do I not have anybody who can give a response in the live chat box whether you can do this problem on your own or not? No. Okay, fine, that's not a problem at all. After you learn this concept, you will be able to. So far so good. The ball will take a time t1 to go up. Okay, now it will stop, and it will take a time t2 to come down. If I add t1 and t2, that's all. That is the time it takes to strike the ground. Okay, Akshat is saying I'm getting t1 as 1 second. Let's see whether it's 1 second or not. How do you do it? So just look at this part first. Forget about this second pink part. Just look at the first pink part, and I will apply. How does my first pink part look like? First of all, what is this motion like? You have a blue ball that's going up, and there is one thing. There is an acceleration g which is acting down. Correct? Gravity, which results into acceleration due to gravity, g, which is 10 meter per second square, that is continuously acting down. Your object will keep going up only. Object is going up only all the time, but gravity is acting down all the time. Okay, so doesn't this equation look something similar to, doesn't this motion look similar to this, where an object is moving along a straight line and you have an acceleration which is opposing that motion continuously? Isn't this and this the same thing? Yes or no? Hello Asif, good afternoon, welcome. Come on, people, type yes or no. Do you find similarity or no? Yeah, Akshat, thank you so much for always being the one who responds. Okay, so now it means that I can use these equations. It means I can use these equations because it is confirmed that my motion is uniform, one-dimensional uniform acceleration. It is confirmed. I just ran the test and I have diagnosed that it falls under this category. So I can use any of these 4 equations. But the question is, which equation do I need to use? Which equation do I need to use out of these 4? That is the question. So I have the initial velocity vector available with me. I know that when the object goes on top, its velocity will become 0. Right? When the blue ball is on top, what will its velocity be? It will be 0. So I know the final velocity. I know the acceleration, a bar, whatever that a bar is, I know it. I just need the time. So I know v, I know u, I know a, I need time. Which equation should I use? This one, right? Because I know final velocity, I know initial velocity, I know acceleration, I just need this scalar. So be it so. Let me use this equation now. So let me hide myself, people, because I need more space on this page itself. Okay, so I need to use this equation. V bar is equals to u bar. I want to learn high school mathematics. Yeah, we are using mathematics that's even beyond high school. And you are a little late, Asif. We are done with the bridge course already, so you can watch those if you want. Okay, so we will be using this. Right, now the thing is, look at these quantities carefully. I know I'm going slow, but this is the first time, that's why I'm going slow. I'm getting answer as 1 by root 11, 1 plus root 11 seconds. No, Akshat, that's not the right answer. That's nowhere close to the right answer. Please keep following. Okay, let's go slow. Let's go slow, people. There's no need to hurry up. It's your first problem. So okay, fine. We have to use this equation. Vf bar. What is this, fellow? It is a vector, and this vector tells me the final velocity. Final velocity, as I said, when the object reaches, when the object reaches on top, its final velocity will be 0. So this is a 0. This is a 0 vector, 0 bar, you can say, okay, is equal to initial velocity. What is the initial velocity? Remember, I need to use the initial velocity vector. I know the magnitude of this vector 10, but I don't have the direction. I need the whole vector. I know its magnitude, but I don't know the direction. What is the direction? Since it's projected upwards, this is I cap, this is j cap, this is k cap. Your object is projected up, right? And I have told you before in vectors already, how is direction represented? It's represented using unit vectors. So I need the unit vector along this direction. What is the unit vector along this direction? J cap, correct? Because it's positive y-axis. So j cap, okay, fine, plus half times, I need the acceleration vector now. I know the magnitude of acceleration vector is 10. That's given to me. But I don't need I don't have the direction. I need the direction also, because this a bar that you're seeing is a vector and not a scalar. So how will you get the direction? You need the unit vector in the downward direction. So if upwards it's j plus, what will be the unit vector in the downward direction? Minus j cap. So minus j cap into t. That's all. That's all, people. So you have a minus 10 j cap is equals to half into 10 into minus j cap into t. Now this minus can be pulled out. In fact, this minus and this plus will get cancelled with each other. It will become plus on both sides. So you have 10 j cap is equals to half into 10 into t j cap. This entire thing is the scalar. This is the scalar. This is the vector part. This is the vector part. I can cancel the vector part now because it's common on both sides. So I can just equate 10 with half 10t. Okay. So 10 equal to 5t, t equal to 2 seconds. Awesome. Okay. So the object takes 2 seconds to go up. Alright. How much time does it take? 2 seconds to go up. Okay. Now I need this. I need this time. How do I get this? So to get this time, I need this displacement, how much it has come down. And for that, I need to know, I forgot class 9th physics. Okay, that's not a problem, Akshat. You will recall everything as you keep learning. But I can see, in the middle of the live session, people drop off, then they join. If you drop in the middle, then how will you learn? Anyways, I'll continue teaching. That is my job. I'll do it. So as this object goes up, it would have covered some displacement. If I get that displacement and I add if I add 40 meters to it, I will get the total displacement that the object has gone up. So I also need that in this 2 seconds that the object went up, how much displacement did it cover? For that, I will have to use this equation. S bar equals to u bar into t plus half into a bar into t square. So S bar, which is nothing but S j cap, because from here as the object goes up, the displacement vector will be positive upwards, right? S j cap. This is u t. Where what is your u vector? What is your velocity, initial velocity vector? 10 j cap. We have already seen this. Into time, we know it is 2 seconds plus half into acceleration vector. We have already seen it is 10 minus j cap because it's downwards, correct? It's downwards into t square, which is nothing but, what is this? 4. Okay. So Sj cap is nothing but 20 j cap plus, this is how much? 4 into 2 minus 20 j cap. Why am I getting a 0 here? I shouldn't be getting a 0. There is probably some mistake that I have done. Let me just see it quickly. Or did I do some mistake here while calculating time? Oh, shit, I wrote the wrong equation here. This is not half AT. This is V, final velocity vector, plus A bar into T. Okay, please forget about this half. I wrote the equation wrong. There will be no half. Which means my T will be 1 second. Okay, in the next page, T will not be, this will be 10 only, and T will be 1 second, not 2 seconds. Sorry, people, my bad. It has taken 1 second to go up, not 2 seconds. Okay, so instead of T equal to 2, I will be using T equal to 1 here. Okay, 1, which means I will have a 10 here, I'll have a 10 j cap here, and I'll have a minus 5 j cap. Yes, please revise kinematics. Even if you don't revise, if let's say you did not know kinematics, okay, and if you just attended this class from the beginning, if you just know that, okay, these are the equations that I will have to use, and you slowly follow what I'm doing, it will be good enough. Like, you won't really have to go and read the whole thing again. It's not really needed. That's completely your call. Anyway, it's not a bad thing to read. Okay. So S equal to ut plus half at square, 10 into 1 plus half into 10 into t square. Okay, 5. That's all. Okay. Now, 4. So this is 5 meter. What is this 5 meter? 5 meter is the length of this. How much it has gone up. So if you look its total height from the ground, it's nothing but 40 meter plus 5 meter, which means the object is 45 meters high. So now the object from the ground, it is 45 meters high, and now this object has to come down by 45 meter, and I want to know how much time it will take to come down, right? So which equation will I use? Again, I know the displacement. Now the displacement will be downwards, correct? Since the object has to travel down, it will be, displacement vector is going to be minus 45 j cap, which means it's nothing but 45 minus j cap, right? I'm using the displacement vector here, people. Notice, I'm not using minus 45, I'm using 45 minus j cap. Okay, so I know this. I know that the initial velocity vector is 0, correct? Because the object is starting from rest. When it has gone up, it would have stopped, and then it will start coming down, right? So initial velocity vector from this position is 0. I know that the acceleration is g minus j cap, because acceleration is still going to be down only, and I need t. Which equation will I use? S bar is equals to u bar into t plus half into a bar into t square. I will be using this. So S bar, which is nothing but 45 minus j cap, is equals to u bar, which is 0 into t plus half into g minus j cap into t square, and this t is what I need, correct? So look at this minus and this plus will get cancelled, because this part is anyway 0, okay, and this j and j also will get cancelled. So finally you will be left with 45 plus half into g is 10 into t square, okay. So t square equal to 9 and t is equal to 3 seconds. Actually you should say t is equal to plus or minus 3 seconds, because when you square minus 3 also you will get 9, and when you square 3 also you will get 9, which means whenever you have this equation t square equal to 9, t can be both 3 and minus 3, but time can't be negative, right? That's why we neglect this minus 3 and we only take the positive value. So we know that t2 is 3 seconds now, correct? So guys, what did I get out of this problem? I'm telling you, problems are going to get difficult. If you don't know how to apply vectors to problems, things will start getting confusing. And please don't panic. This is your first problem, first ever 11th class kinematics problem that we discussed in the class. So sorry, there's no person here. We had a tower of 40 meter, ball was thrown, it went up by 5 meter, and it took 1 second for this, and then from the top it came down by 45 meter, and how much time it took for this? 3 seconds. And the question was, from the beginning, how much time has it taken by the time your object strikes the ground? So time taken, total time taken is nothing but 1 second plus 3 seconds, which is 4 seconds, and this is your final answer. I have very few people in the live session, so I can't even ask if people understood the whole solution or not. Okay, so this was an interesting problem, and I'm telling you, there can be hundreds of problems of this type. Just in this one thing, there can be hundreds of problems. Let me give you one more quickly. This is again a little it's more tricky than the previous one. A ball is thrown upwards from the ground with an initial speed of u. Okay, the ball is at a height 80 meters at 2 times. At 2 times, the time interval being 6 seconds. Very tricky problem. Find u, take g is equal to 10 meter per second square. Now these problems will give you a nice welcome to IIT JEE physics. You know, it's begun. It's begun. It's begun already. Now is the time when you will realize that without the knowledge of vectors and those things, life is going to be very difficult for you. So 80 meters at 2 times. Yes, Akshat. Let's see. Let's first try to understand the problem. I will not really solve it today. I will solve it tomorrow because it will take time. But just let's try to understand it. So a ball is thrown upwards from the ground with an initial speed of u. Okay, I've underlined that much part. I will draw the diagram for that much. So this is the ground. Here is your ball, and ball is thrown upwards with a speed of u. Okay, this is my u bar vector. Okay, I have to treat them as vectors repeatedly after I've been telling you. Okay, the ball is at a height 80 meters at 2 times. Okay, how is this possible? For this you will have to visualize the motion. Okay, so what will happen is the ball will go, and let's say right now it is at a height 80 meters. 80 meters. Okay, then it will go up. It will keep going up. It will stop. After some time it will stop. Then what will happen? It will start coming down again. Let me start drawing the downward scenario on slightly to the left, slightly to the right. Okay, so now the ball will start coming down, and then once again it will cross this 80 meter mark, right? So once again the ball is at a height 80 meter, and now it will continue to come down, right? So remember, these are not two balls, it is just one ball, and this whatever this going up and coming down, the thing that I've drawn, it's happening in the same line only. It's happening in the same line. I have just drawn them separately so that you can see the upward and the downward part separately, but actually this up and down, they are like along the same line. The same line, ball goes up and comes down. Okay, so what they have given is the time interval being 6 seconds, which means, look at this, the ball will take time t1 to go all the way up to its highest point from this 80 meter mark, and it will take a time t2 to come down from the highest point to the 80 meter mark. This t1 plus t2 is given to be 6 seconds in the problem. So which means the time interval between the instant when it crosses 80 meter for the first time and when it goes up and comes and crosses 80 meter for the second time, the time interval between these two instances is 6 seconds. That's given. And using this you have to find u. So they have given some random data from the motion, and now they are asking you to find u. Tricky. Not a simple problem, to begin with. But I wanted you to get a flavor, that when you actually master T1 and T2 is equal, we don't know, Akshat, they might be equal, they might not be equal. When you write the equations properly, you will know whether they are equal or not. But the point is, we have to use this data somehow. So actually I will close here. I will not solve this problem today. I want you to try this on your own. Okay? Think of the various ways in which you can do this problem. And I can tell you that this problem can be done in multiple ways. not just one way. Okay, it can be done in multiple ways. One of them I can just give you a hint. Just look at this part of the motion first, this part, get the final velocity here, whatever that is, and then using this part, using this velocity, analyze this part where you will know the final velocity, you will know the initial velocity, you will know the acceleration, you just have to find t1. Do the same thing for this fellow and then use this equation. That will give you the answer. That will give you what u is. Kinematics problems are like that. When you use the equations properly, and I'm telling you, to solve this problem, you don't need anything more than these 4 equations. You don't need anything more than these 4. But just make sure you use these equations 1, 2, 3, and this 4th one. You use these 4. What is the 4th one? Is here. Yeah. You use whatever is relevant from these 4, but make sure you use them vectorially. Okay. Otherwise, you will make a mistake of the plus and minus signs. Those things will happen. Right. We will solve this tomorrow. Slightly difficult problem, and then we will discuss difference between distance and displacement that we have seen, but we will see it again tomorrow with equations. And then we'll just be left with one thing: one-dimensional motion with your non-uniform acceleration. That's all. One-dimensional motion with non-uniform acceleration. With that, we will finish 1D kinematics, and we will see if we can discuss a little bit of graphs and those things also. Okay, so take care, guys. Stay safe. Bye. Please come live. People who are not watching these things are missing out on extremely crucial stuff, and you will only have yourselves to blame if you struggle with 11th and if you struggle with the 11th class physics. Okay. Stay safe. Bye bye. Take care.